I'm Kendra Little for Redgate Software. And in this series on designing database changes for high uptime environments, we are now going to talk about some gotchas that can lead to problems in production that you did not detect in the development or testing part of the software development lifecycle. So we're covering patterns that have burned me and folks I know in the past, so you don't have to be burned by them. One important thing to know is that while it is just absolutely fantastic that Microsoft now gives us Developer Edition for free for non-production purposes, Standard Edition, which many people run in production, does not have the exact same features as Developer Edition. Developer Edition has the same features as Enterprise Edition. So in Developer Edition for SQL Server, you can create an index with online equals on to minimize the amount of time that exclusive locks are taken out to make the table more highly available while the index is being created. But that's not going to work if you're deploying to Standard Edition when it gets to production. There's other features like TDE that Standard Edition doesn't support. And of course, we do have performance limits in Standard Edition that we don't have in Developer/Enterprise Edition as well. Now, it's important to know what version you're developing of SQL Server. As of 2016, Service Pack 1 and higher, Standard Edition has way more cool stuff in it. This is an amazing thing that Microsoft gave to us that I'm still really excited about. So if your production instance is running 2016 Service Pack 1 or higher, and it's Standard Edition, you can use table partitioning now. You can use data compression now, and you get more features there. So knowing what version of SQL Server you're developing for is very important, and in part just in terms of what features will work there. We also got column store indexes and in-memory OLTP, but do note that you want to be careful there because these features are limited in terms of production on Standard Edition, right? The limits you see on this screen are for Standard Edition, not for Enterprise Edition or Developer Edition. So make sure that if you do plan to use these features in production, that you are going to be okay with these performance limits if you're running on anything other than Enterprise Edition in production. We also just have some performance features that are enterprise only. If you pay the big bucks for Enterprise Edition, you get larger read-ahead reads for faster population of your buffer pool in memory from the data. You also get some really cool features like automatic tuning, some batch mode, which can increase performance as well. This means that if you are developing on Developer Edition, right, which is a great fit, you might actually see some of these things working in ways that they are not going to work when that workload hits production if it is not on Enterprise Edition. And one very cool feature for Enterprise Edition, but that can be a big gotcha if you don't have Enterprise Edition, is this one. When you add a new column in a table, if you make it non-nullable and you give it a default value, as of SQL Server 2012 and higher, Developer Edition is going to be quite good at that because we got this feature in SQL Server 2012 that makes this kind of a magic metadata operation. So in development, adding a non-nullable column with default values will, even on a very large table, really fast because it's just got to update metadata. If that same change deploys against SQL Server 2012 and higher, but deploys against Standard Edition, it is not a very fast online operation. It is what is called a size of data operation in which SQL Server needs to go throughout the entire table and update that value row by agonizing row. And on large tables, this can be incredibly slow. So if you run Standard Edition in production, be very, very careful when adding new columns. Have a checklist for your developers that helps them know there are some gotchas with this. It's also a best practice to build your code on the version that you'll deploy to because there's just functionality that we get in new versions of SQL Server that exists in T-SQL. So some of my recent favorites, right? We get a lot of syntax, but some of my recent favorites are that we got drop if exists in SQL Server 2016, but that's not going to deploy successfully against SQL Server 2014. It's going to say, what is this syntax? We later got creator alter and some option use hints. So a best practice is definitely that when you are validating your code, which I like to do in an automated build, at Redgate, we sell products that help you do that. So full disclosure, I'm not advertising something that's free. But when validating your code, validate it against an instance that matches the production instance in terms of the version, because you want to make sure that you've got syntax compatible with where it's going to in the end. When you're looking at data before it gets to production, this may or may not be on your build server, but if you want to know things about, hey, what index is this query likely to use? Or about how long is this going to take? Running the query against a database that has a similar data size and distribution to production matters a ton, because SQL Server thinks about a lot when it thinks about optimizing a query. It thinks about how many rows am I likely to return. It also thinks about how much parallelism should I use for this, right? And that is going to vary based on a lot of factors. It's going to vary based on how many cores I have and what my settings are on the server, for instance. So the data size and the distribution matter a ton to query performance. And the more you can make your development environments production-like, the more of an understanding you're going to have of how long it will take for the query to run. Now, you may or may not want to have full data sets in every place. So for example, when you're running a build, generally we want our build to be fast. And generally we're using a build for code validation rather than any sort of performance measurement, right? We want to know, does all of the code create successfully from source control? We want to build that against an empty database, right? So it is desirable for the purpose of a build to build empty. But for other parts of our pipeline, like when we're deploying a change to in a pre-production environment, we really want to know from deploying to a pre-production, also known as staging environment, hey, how long is this deployment going to take? So we really want that environment to have really, really very similar data sizes and distribution. There may be other environments that we want to do performance testing in where that's going to be very important as well. If we are manually testing query performance, maybe we're researching, right? Before we've ever even, committed our code. Maybe we're researching, hey, what are the different ways I could write this query and which one is faster against a dev server? Well, I do want representative data sizes to test that, and I want, maybe not an identical machine, but as similar as I can get. When I am testing those queries, I also want to think about measuring in a way that is consistent. So personally, when I am testing a query, I like to be consistent about whether the data is in memory or not. I might run commands to clear out the memory on my dev server, just commands on my private dev server that says, hey, clear out the memory on the dev server, so that every time I run it, I'm running against a cold buffer pool, cold clean buffer pool, just because that makes each run consistent. Because if the first time I run a query, I'm populating the buffer pool, especially if the storage on my development machine isn't very fast, that's going to take longer than running the query a second time when the data is in memory, especially if a lot of it fits in memory, right? So I want to be consistent there. I also tend to want to take more than one measurement. If I'm testing on something like my local laptop or a virtualization server against a container where there could be a lot of other stuff running that impacts that environment, multiple samples are helpful to get consistency. And then this final thing is, I want to also think about parameter sniffing when I'm testing queries. Parameterized queries, stored procedures, both, the first time the query compiles, unless I've done some special work to make it not happen, generally, SQL Server is going to sniff the parameter values that I pass in. It's going to use that to optimize the query, and it's going to think about the data distribution in the context of those parameters. if I want to know how my query is going to perform with different parameters, I will want to clear the execution plan cache periodically to say, no, compile with these other parameters. And then what happens if I rerun you with different values for those? So for all the things I just talked about, when you're manually testing, and again, these are things we don't want to run against. These are not commands I'm saying to run against production. These are not commands that I'm saying to run against a shared instance. But on my private instance, where these aren't going to bother anybody else, I can use a checkpoint to flush dirty pages to disk. I can use dvcc drop clean buffers to say, hey, clear out the buffer pool. I want to read everything from disk again to give me that consistent performance every time I run it. And I can use a command like dbcc free proc cache to say just clear out all the execution plans, start fresh. So these are commands that in a private dev environment can sort of reset you performance-wise to get consistent performance so you can really tell, have I made the query faster, instead of just telling, oh, well, I just used things that were already in memory and now it's faster, which can be quite confusing. If we do run these commands, in shared environments, of course, we risk messing up other people's testing outside of production. And if we were to run these in production, we might mess up performance in production too. So these really are just for those private environments. In my private dev environment too, if I care about performance, I want to be as production-like as possible. If you've got monster production hardware, this may or may not be possible, but you want to think about these settings. You want to think about the cost threshold for parallelism. What do you have in production? What do you have in your dev environment? You want to think about the max degree of parallelism. And, if you don't have enough cores to match prod, you definitely want to have more than one core, right? Because you're never going to go parallel if you just have one core. So get as close as you can. And you do want to think about how you have configured the memory that SQL Server can use, right? So you want to know what your settings are. These settings all matter a lot when it comes to query optimization. And know that if your environment and your data doesn't match production, you're probably not going to get the exact same plans as production. The idea in an environment that isn't completely similar is more about estimating the performance you're going to get rather than proving the performance you're going to get. Because SQL Server does care about how much memory you've got when it's thinking about how do I optimize this plan. Another thing to think about when designing changes, we're shifting context a bit, is that when you're authoring changes, there are certain changes that require you to be the only active user in the database. Now, this isn't a lot of commands, but things like, what if I want to turn on the read committed snapshot setting for a database? This snapshot changes the behavior of the default read committed isolation level. And there's you need to do a bunch of research before you turn this on, right? This is not a risk-free change, but this is one of those changes that you want to throw everybody else out of the database temporarily to do this change. If you need to do a change like this and you have a high uptime environment where you can't just get a downtime window, the syntax on the screen here that says change this setting with rollback immediate is very, very useful. And I would prefer this syntax to, I would prefer this. I would not prefer a syntax that does multiple commands that say, put the database in single user mode, make this change, then put the database in multi-user mode. And you might think those sound similar. I think they sound similar. But I've had some experiences when I put the database in single user mode on a very busy system where a really weird deadlock happens in SQL Server. And it's actually pretty hard to reproduce this behavior, but I've seen it happen in production where if you try to put a database in single user mode, what I've seen happen is that there is a weird deadlock that occurs and you become the deadlock victim and someone else becomes the single user of the database. This can be awkward to fix because if you try to kill their command and it's a busy system, someone else can get the single user mode before you can again, right? So the syntax on the screen, which is simpler, which does not require putting the database in single user mode, this will impact other sessions. This setting that's changed, the with rollback immediate clause says anybody else who's running, kill them, roll them back. Then do the setting, then immediately release it, right? So if you do have to do a change like this, yes, this change does have impact on other settings with the syntax I have here, but it has less risk than the single user mode option. And I have seen that I tried to put the database in single user mode, and I am not the single user. I have seen that on multiple versions of SQL Server. I've never been able to reproduce it in a very simple way that allows me to escalate the bug. So it's one of those very, very frustrating things that's burned me. Another thing, when modifying data, batch size is incredibly important when it comes to performance and availability. When we start learning how to write code in SQL Server, sometimes we hear that small transaction sizes are better, right? Do a little operation and it's less work. But this is not completely true, it turns out, because every time we commit a transaction, SQL Server has to flush it to the transaction log. So if we need to, say, delete 10 million rows, and we do them one by one by one, that's 10 million flushes to the transaction log, and that can impact performance. You can end up with waits on your transaction log because it's so busy constantly flushing everything to the log. So you might want to delete more rows, but you got to be careful how many you delete. Because if you delete a lot of rows, and this is a highly available database that needs high uptime, you could end up blocking a ton of stuff by having your deletes escalate and lock the entire table. So this is a little bit like, a fairy tale. We don't want a batch that's too little. We don't want a batch that's too big. We want a batch that's just right. The way I like to handle this is when you're writing a script that needs to do a bunch of data modifications, set it up to do a loop, and make the batch size configurable with parameters, and make the number of iterations configurable with parameters. Because in my experience, especially when we get to production, if we've got something like transactional replication or availability groups or anything that synchronizes our data with other systems, we may want to run our modifications for a while and then wait, if that's acceptable. Let everything catch up because we've just turned a bunch of changes into our log, and then run some more. So I like the scripts to be very, very configurable in terms of both of these items. That way you can test in a pre-production environment. Is this script the way we have configured? Is it using indexes and the best way to make this the most efficient? And is it not having a heavy impact on performance? Are we having as minimal an impact on performance as we can? And with these two things configured as parameters, we can really work that out in a production-like environment before we actually go to production. What about fast order deletes? What's this? This is a pattern that's really, really interesting. And if you do need to do deletes, you may want to use this pattern. This is a really classic one. It was originally published on the SQL Cat Team blog. They are no longer the Cat Team. They're now, I believe, the Tiger Team. They're a larger cat now. And the Microsoft blogs have become very hard to find posts. And you'll see at the URL on the bottom that this was posted in 2009 on the SQL Cat Team, but I got a link here to the Wayback Machine because it's actually hard to find the real post now. John Sansom actually wrote a great post summarizing this as well. The essential trick is you can sometimes get a much better execution plan if you need to delete rows by creating a view with top and order by and then deleting from the view. So it's a fairly weird thing to memorize. Just know when you're looking at, oh, I need to delete a bunch of rows from this table, remember that you want to look up fast ordered deletes and keep these URLs somewhere handy. Review the pattern there when you're authoring the code and you'll get there. As you've heard from a lot of these tips, having a production-like staging, aka pre-production environment, is key. Because in most of our worlds, we just aren't going to have dev servers that are that production-like. And in high uptime systems, often performance is key. So that deployment to that staging environment is really where we learn some very critical things about how exactly do we want to execute this change in production, right? Do we want to make any changes to the query before it goes out? What is the duration going to be like? Now, you might wonder, is there a way we can shift this left, right? What we don't want to do is we don't want to spend a lot of work on a change and then have it go through a very long release pipeline, then get to staging and then get stuck. For this reason, the staging environment maybe shouldn't be at the end of our development line, maybe staging. Now, often staging is the last stop before we hit production. But for a DevOps cycle, what we really want to do is identify errors early on. We don't want to do all the work and then have to start over, right, later on. For a DevOps cycle, I would encourage you to give folks access to a very similar environment as much as you can early on, maybe at the point where, if you're using Git, maybe at the point where you're doing a pull request. At the point where you're doing pull request, having a very similar environment that can be looked at in terms of performance at that point is great. Because then if the performance looks like, yeah, this isn't going to be a good deal, then, right, we've short-circuited much earlier in the cycle and we can just go back and tune it there. So I think not only having a staging environment is important, but really thoughtfully think about how can you use this earlier. It may be an investment. Maybe you end up with multiple staging environments so that one can be deployed to before things hit production, but this can be an extremely valuable investment in terms of making developing code more productive and identifying potential problems earlier on, empowering people to figure out, okay, we have these performance requirements and we need to meet them at the point where we're merging our code into a branch where it's going to move into an automated deployment cycle. So thinking through the best way to use staging environments really, really helps prevent those gotcha moments when you finally get ready to deploying to production. Thanks for joining me for this series on designing database changes for high uptime environments. I'm Kendra Little from Redgate Software. Bye, folks.